Have you ever wondered just how far our nearest neighbour in space truly is? Did you know we live in the Milky Way galaxy with approximately 400 billion other stars? Well, that's a fact. And Proxima Centauri is the closest star to our Sun, a mere 4.2 light-years away. But what if I told you that one of its exoplanets, Proxima B, has recently made some headlines? Well, we are all set to colonize a new world. We're just waiting for the green light. So, are you ready to join this cosmic journey to the Alpha Centauri system? Before we do this, let me remind you, if you enjoy our space exploration content, hit that like button and subscribe to our channel to stay updated. Let's uncover the mysteries of space together. Imagine launching towards Alpha Centauri, our closest star system, aboard the fastest spacecraft ever built by humans, the Sun-observing satellite Helios 2. Traveling at a mind-boggling speed of 157,000 miles per hour, that's 0.023% of the speed of light for all you science buffs, it would still take us a whopping 18,000 years to get there. The cosmic scale is truly mind-blowing, and it hits home how important it is for us to study our cosmic backyard if we ever hope to witness a sunrise from a different star. We can't afford to wonder because the stakes are too high. And that's why Alpha Centauri has had us turning our telescopes in its direction time and time again. In Alpha Centauri, scientists spotted not one but two new stars, Alpha Centauri A and Alpha Centauri B. Both are sun-like yellow dwarf stars, appearing as a single star to us down here on Earth. Shining as the third brightest star in the night sky, this star system has caught the eye of civilizations from summers long past to the ancient Egyptians, even finding a place in Ptolemy's writings. The serious scientific study of Alpha Centauri kicked off in 1915. With British astronomer Robert Innes discovering a third star in the system, a red dwarf named Proxima Centauri. To this day, Proxima Centauri is the closest known star to our Sun. Just about when we began studying our nearest star in detail, the golden age of science fiction and space opera was in full swing. Coincidence? I don't think so. The relatively short distance to Alpha Centauri sparked a creative wildfire. The possibility of a different world under a different sun, home to entirely new civilizations, was tantalizing. This caught the fancy of imaginative minds from James Cameron to the Strugatsky brothers. The result? Alpha Centauri skyrocketed in popularity, featuring in the works of sci-fi writers, artists, movie directors, and even music composers. It forever cemented its spot in our hearts as the go-to place for potential extraterrestrial life. However, as it often happens, reality was much grimmer. Our initial enthusiasm shifted towards the search of exoplanets for a glimmer of hope, a signal, or even circumstantial evidence of life on far-off planets. And indeed, scientists found two planets in the Alpha Centauri system, that's Centauri AB and Centauri BB, that seemed promising. Well, upon closer inspection, both planets unfortunately turned out not to be habitable, at least as we know it. But don't lose hope just yet. The year 2016 brought a game-changing discovery. After years of relentless searching, scientists confirmed the existence of an exoplanet in the Alpha Centauri system. And guess what? This exoplanet orbits around our closest neighbour, Proxima Centauri. The planet, named Proxima Centauri B, is a mere 4.22 light-years away. Its discovery is nothing short of a miracle, as it's only 1.1 times the mass of Earth. This was a painstakingly slow process, confirmed by measuring the radial velocity of the planet as it passed across the disk of its parent star, Proxima. But the story doesn't end here. In 2019, the Parkes Observatory in Australia recorded strange radio signals over 30 hours. These signals, potentially from Proxima Centauri B, were at the frequency of 982.002 MHz. And what does that mean? Well, it means Proxima Centauri B still has some surprises up its sleeve. We're sure you're wondering, how did scientists decode all this? Well, to explain would need another half hour, but let's keep it short. They noticed a frequency shift in the signals, matching Proxima Centauri B's orbital movement, and then the signal mysteriously vanished. Several attempts to establish a connection again were made, but no luck. The chances of a species being in the nearest star system and technologically advanced enough to produce radio communication are 10 to the power of -8, which is extremely low in plain English. Since 2017, astronomers watched Proxima Centauri closely using the Atacama Large Millimeter Array. They observed the red dwarf star making coronal ejections, causing flares that increased over 1,000-fold over 10 seconds. Any life on Proxima Centauri B would be absolutely bathed in lethal radiation from flares such as this, which are quite common for Proxima. This also suggests that the planet's atmosphere was likely blown into space. Another hurdle for life on Proxima Centauri B is its proximity to the star. It orbits around its sun in just over 5 Earth days, so close that even a cold red dwarf star would blast too much heat for water to remain liquid on the exoplanet itself. But this is not the end of the story. Using the espresso spectrograph on the VLT, scientists from 2020 to 2022 observed the transit of a small object smaller than Earth. This object, dubbed Proxima D, was discovered using the radial velocity method. It's one of the most promising mini-Earths for future studies. Its radius is estimated at 0.8 Earth radii, and its mass is twice that of Mars. We haven't determined if Proxima D is habitable yet, but its existence suggests that there are many more exoplanets out there that we haven't seen yet. Our methods for discovering exoplanets are limited today to the transit method and Doppler spectroscopy. These methods work well for giant exoplanets, but smaller ones like Proxima B are much harder to detect. Of the 32,073 exoplanets in the NASA archive, only 36 are smaller than Earth. As our technology advances, we hope to find smaller and smaller exoplanets, and we are getting there. As we head into the future, the James Webb Space Telescope promises to revolutionize our understanding of these distant worlds. It may help us detect the presence or absence of an atmosphere on Proxima Centauri B, and maybe, just maybe, if we're lucky, signs of life. So, you can say that the future of studying exoplanets looks bright. But what about actually visiting them? Breakthrough Starshot is an ambitious project aiming to create spaceships capable of reaching Alpha Centauri in 20 to 30 years. Despite its challenges, this initiative has attracted interest from many. Finally, let's revisit the possibility of life on Proxima B. Despite the harsh radiation from Proxima Centauri's flares, life could theoretically exist there. Organisms might take refuge under the planet's surface or deep in water, and might even have protective proteins that convert UV radiation into biofluorescent radiation. In short, we might dig a few feet down and discover a civilization of glowing creatures. Studying exoplanets allows us to explore one of the most significant questions in history. Are we alone in the universe? Time will tell whether Proxima Centauri B is unique or just the first of many similar worlds. What's certain is that our quest for answers will continue to drive us forward in our quest to answer that eternal question, are we alone in the universe? That's all for today, folks. If you enjoyed this cosmic journey, don't forget to hit that like button and subscribe for more fascinating space exploration content. Keep looking up, and as always, stay curious.